This is the Unit 6 video for the Honors Algebra 2 exam review. Unit 6 was on sequences and series. All of these formulas, well, at least the box, this formula over here, this will be on your exam on any page that has sequences and series, so you just need to know what the formulas are, what the letters mean. You won't have the box that says N is the term number, D is the common difference, but you'll have all of the actual sequence formulas and series formulas over here, so you don't have to memorize those. Number 1 asks you whether the sequence is arithmetic, geometric, or neither. And if it is arithmetic or geometric, you need to state the common difference or ratio. Alright, so A has 576, negative 288, 144, negative 72. My first hint is that this is going to be a geometric sequence because we're alternating signs. This term is positive, negative, positive, negative. And when you're alternating signs, that typically means that you're multiplying by a negative number. So if you forget, the way we take or find the common ratio, if it is indeed geometric, is to take the second number divided by the first number. So if I take negative 288 divided by 576, I get that there's a common ratio of negative 0.5. So that's what I think the common ratio is, but I need to check. I need to verify that the common ratio between those two numbers is the same as the common ratio between the next two numbers. So I would take the third number divided by the second number. You could probably see already that that common ratio is negative 0.5, but if not, you can put that into your calculator and make sure that you get negative 0.5. So that means A here is geometric, and that the common ratio is negative 1/2 or negative 0.5. It doesn't matter how you write it. B, you go 2, 15, 28, 41. All the signs are the same, so it could be either arithmetic or geometric. It looks like we are 2 to 15. It looks like we're going up by 13 for that one. 15 to 28, you're also going up by 13. So this sequence is arithmetic, and there is a common difference of 13. All right, C, 3/4, 2, 13 over 4, 9 over 2. All right, this one's a little harder to tell because there are fractions. So why don't we try geometric first? Let's just see what happens. If I take 2 divided by 3 over 4, and we can let our calculator do the work for us here. 2 divided by 3 over 4, 0.75, is 2.633. Okay, so if this is indeed the common ratio, when I divide the next two numbers, 13 over 4 divided by 2, I should get the same common ratio. So let's see. 13 over 4 divided by 2. Oh, I don't get the same common ratio, so that means that the sequence in C is not geometric. Okay, so we know it's not geometric, but it could still be arithmetic or neither. So for arithmetic, if we can't find the common ratio just by looking at it, you do the same type of thing as we did with geometric. You take the second number minus the first number. So if I do 2, you can probably do this in your head, but if not, 2 minus 3/4, I get 1.25. All right, now if I take the next two numbers, 13 over 4 minus the 1 in front of it, which is 2, if I get the same thing, then I'll know that this is an arithmetic sequence. I do get 1.25, so that means that there is a common difference here of 1.25, so this sequence is arithmetic. All right, so number 2, similar kind of problem. You have to decide if it's arithmetic or a geometric sequence. Find the common ratio so that you can fill in the blanks. Okay, so we're going from, in A, 9 to 16 to 23. It looks like, let's see, let's try arithmetic. 9 to 16, you're adding 7. 16 to 23, you're also adding 7. So this looks like it's arithmetic. And just so we know here, the common difference is 7. So if I keep adding 27, or adding 7, 23 plus 7 is 30, plus 7 is 37, and then 44. Now the next one, 100, negative 200, 400, our hint for that is that it's geometric, just like in number 1, because we're alternating signs, positive, negative, positive. To find the common ratio, take the second number, negative 200, divided by the first number, and you get a common ratio of negative 2. And that does make sense because negative 200 times negative 2 would be 400, times negative 2 will be 800, 1600, negative 3200. So again, this is geometric, and your common ratio is negative 2 there. All right, the next one, negative 8, negative 5, negative 2. They are negative, but these signs are not alternating, and it looks like you're adding 3 every time. Negative 8 to negative 5 is plus 3, so you'd end up with 1, 4, 7, if you kept adding 3. And since we added, this is an arithmetic sequence with a common difference of 3. All right, so those are just making sure you can identify and find the terms and common ratio and common difference of sequences. Let's do a little bit more here. All right, we're given a sequence 9, negative 36, 144, negative 576. How to tell if it's arithmetic or geometric? Well, just like the other ones, we are alternating signs here. Since we are alternating signs, this is going to be geometric. Right? You're not going to alternate signs when you're arithmetic. So to find the nth term formula, first thing I need to know is the common ratio. So if I'm looking for the common ratio here, I take the second number divided by the first, and that gives me negative 4. Now to find the nth term formula, it's on, the formula is up here. I didn't put them on every page of the file here. But the a sub n formula is the first term times the common ratio to the n minus 1 power. Well, in this sequence, the first term is 9. So the formula is 9. We just found this r over here to be negative 4 to the n minus 1 power. That is the formula for this sequence. Now, if we want to know what the value of the 10th term is, that means that we're looking for where does n equal 10? What is the 10th term? So we're going to find a sub 10 here. So we'll take 9 times negative 4 to the 10 minus 1 power. Use your calculator to help you here. 9 times negative 4 to the 10 minus 1 or 9th power. And this is the term that you get, negative 2,359,296. All right, hope you're good there. Now it says in D, what is the sum of the first 10 terms? There are 2 ways that you can do this. The first way would be to use the series formula, S sub n. Okay? So if we do that, let me write the formula down here for you. Okay. That is the formula for the sum of the series. You are welcome to use this formula. So let's see how it works, and then I'll show you the second option. If I use this formula, I put a sub, it shouldn't be a sub n, I'm sorry, it should be a sub 1 right here. I put 9 in for a sub 1 times 1 minus my common ratio. Remember, if your common ratio is negative, you put it in parentheses. To the nth power, and here is 10, all over 1 minus negative 4. So if I use my series formula like that, I go back to my calculator, and I type that in really carefully. Make sure that the 10, the exponent there, is inside the parentheses, or outside of the negative 4 parentheses, inside the numerator parentheses, all over 1 minus negative 4. And this is the sum of the series. Negative 1,887,000. 435. Okay, so that's if you added up the first 10 terms of this series, you would get that value. So that'd be adding up 9 plus negative 36 plus 144, on and on. That's one way to do it. Not too hard to do that formula. You also have the option of using sigma notation. So if you wanted to, you could use sigma notation here. It says we're trying to find the sum of the first 10 terms, so our indices would be from 1 to 10. And remember, with sigma notation, you just take this nth term formula and put that right after sigma notation. 9 times negative 4 to the n minus 1. And you can take your calculator and type that sigma notation in. If you forget sigma notation, you go math. It's option 0 here, summation, so you choose 0. Remember, we always use x's as our variable when we do sigma notation. We'll do 9 times negative 4 to the x minus 1. And I do the same exact answer. Right? So both ways give us the same value without a problem. So you have choices there. You can do either sigma notation or the series formula. Most of your exam is multiple choice, so truly it does not matter. Use which one you are comfortable with. All right, now we have a different sequence. Negative 40, negative 23, negative 6. Is this arithmetic or geometric? It looks like, let's see, if I go from negative 40 to negative 23, that looks like you are adding 17, but let's double check. We would take the second number, negative 23, minus negative 40. Yep, we're adding 17. And then negative 23 plus 17 would be negative 6. Yeah. So this is arithmetic. Too early to spell correctly. Arithmetic. Alright, so it's arithmetic. We notice that the common difference is 17, and we need to find the nth term formula. Again, it says at the top of the page here that the nth term formula for an arithmetic sequence is this. Remember, I like to put the D on the left. Alright, well, if I'm finding the nth term formula, I need the first term. First term here is negative 40. That's a sub 1 plus D, our common difference, times n minus 1. Now, it says to write this in simplest form, so we want to get rid of the parentheses by distributing the 17 here. So you'd have negative 40 plus 17n minus 17. Then I'm going to scoot over to the right here. We need to combine like terms. Okay. Negative 40 minus 17 is negative 57. I'm going to write it this way, 17n minus 57. But you can put the negative 57 first. That's fine. But that's the equation of the nth term. So you can find any term in the pattern using that formula. And here we're going to find the 10th term. So for the 10th term, you're going to find a sub 10 is 17. And all you have to do is put 10 into the formula minus 57. Well, let's use our calculator. 17 times 10 minus 57 gives you 113. That would be the 10th term in your pattern. Okay. Now it says, what is the sum of 123 terms in the sequence? Well, there are two ways to do this. The fast way would be to use sigma notation, just like on the last problem. If I'm finding the sum of the first 123 terms, my indices are going to be from 1 to 23. And when I use sigma notation with arithmetic, I pull this sequence formula down. And all you would have to do here is type that into your calculator, and you would be all set. So you'd hit math 0. You're adding from 1 to 123. You type in your formula. Let's see. You should do 122,631. Now that is a pretty simple way to find the sum. However, if you forgot about sigma notation or you don't like sigma notation, you are welcome to use the series formula. Now the series formula looks like this. For this formula, I know n is 123. So if I'm trying to find the sum of 123 terms, I would do 123 over 2. I know the first term up here was negative 40 plus, a sub n. That means I need a sub 123. I don't know that value yet. So if I wanted to find a sub 123, I need to use the formula like I did in part C. So I would take 17 times 123 minus 57. So we'd have 17 times 123 minus 57. And that would be the term you're subtracting off. Okay, so adding. Plus 2034. So you would put that into the formula. So then you'd have to type this whole thing into your calculator. So let's try that. So I'll make a fraction here, 123 over 2. And we're starting at our parentheses, or our first term was, negative 40 again, plus 2034. And I get the same exact answer as with sigma notation. So I got the same thing. I'll just put an equal sign here. Got the same thing. It was a little bit more work that way. It doesn't matter which method you use again. Just pick one and go with it and be good at it. All right, number 5 says, again, same kind of thing. Is given the series is the series arithmetic or geometric. My signs are not alternating. I have 1, negative 11, negative 23. It looks like I'm going down. From 1 to negative 11, it looks like I'm going down by 12. Negative 11 minus 12 would be negative 23. So this looks arithmetic. And I want to find the formula again. Okay, so just like in number 4, I'm using this formula here to find the equation. So to find the equation, you have a sub n equals, the first term is 1. We said our common difference is 12, so minus 12 times n minus 1. Now just be careful when you simplify. Some of us made a little arithmetic or algebraic mistakes when we did this on our unit test. So you distribute a negative and you would get 1 minus 12n. A negative times a negative is a positive 12. So when I combine these like terms, I get 13 minus 12n. That is the formula for the nth term here. So all C says is use sigma notation to write the sum of the first 8 terms. Well, we did that above. You've had some practice with that today. We're finding the sum from 1 to 8 of this sequence, 13 minus 12n. You just put the a sub n formula next to sigma notation in parentheses and type it into your calculator. So you do math 0, summing from 1 to 8 of 13 minus 12x. And you get negative 328. Alright, so if you are good at sigma notation, you've had some practice here. If not, we can give you some other problems to work on. Number 6 has sigma notation in it, but this time it says, what's the sum of the series? Show each term in the expansion. When it says show each term, that means you need to show. If we start adding from term 4 to term 7, you need to find what is the value of each term in this sequence here. 4, 5, 6, and 7. So to do that, you're going to put 4 in for x, then 5, 6, and 7, and evaluate. So you're going to have 2 to the 4 minus 7 power. So I can type that. Just like that, you don't even have to simplify it into your calculator, and you'll get 0.125. For x equals 5, you do the same thing. 2 to the 5 minus 7 power. We'll get 0.25. 6, we do the same thing. 2 to the 6 minus 7, 0.5. And finally, 2 to the 7 minus 7, we shouldn't need our calculator for, because 7 minus 7 is 0, and anything to the 0 power equals 1. So all you have to do is add those terms up. Add this column up. 0.125 plus 0.25 plus 0.5 plus 1. And when you add those up, you'll get 1.875. Right? That's what you have to do. Show all those 4 terms that you're adding up, and then put them in your calculator and get your value. All right, just a couple more here in this unit. Max is training for a marathon. It says the first week of training, so that would be A sub 1 when they tell you that, he runs 15 miles. Each week he runs 2 more. Well, if he's running 2 more than the previous week, that means that we have a common difference of 2. How many miles will he run his 16th week? So that means we're trying to find what is it when n equals 16. Well, if I'm just finding a term, the 16th term in the pattern here, we're going to use our sequence formula for arithmetic sequences. You don't have to simplify anything here. You just need to put the values into the equation that you have. I know n is 16, so that means I'm going to find a sub 16. The first term is 15, plus our common difference of 2, times 16 minus 1. So you can go ahead and type it just like that into your calculator. No need to simplify anything else. And you should get that on the 16th week, he's going to run 45 miles. Now, it doesn't say 45 miles at what time, it just means the whole week. He's going to run 45 miles. So that's a pretty simple word problem here for sequences. We have 2 multiple choice. I'm actually going to start with number 9. Number 9 is easier than number 8. So let's do 9, and then we'll go back to number 8. So for this series, it's given to you in sigma notation. Write the number of terms, find the number of terms in the series. Well, all it says is we're adding from terms 1 to 8. So think about that. If I'm adding up terms, sorry, I want to end here. Term 1, 2, 3, 4, 5, 6, 7, and 8. How many terms is that? Well, if you count them up, that means you're total adding up 8 different terms. There's no trick here. It's just B. Okay. You can also remember that a while ago when we did sigma notation, we said one way to figure out how many terms you were adding up was to take the top index of 8 minus the bottom index of 1, and then add 1. Well, 8 minus 1 is 7, plus 1 is 8 terms. So that should be a pretty simple multiple choice question for you. Number 8 is a little less, it is simple once you get the trick to it. So suppose you drop a tennis ball from a height of 15 feet. After the ball hits the ground, it rebounds to 85% of its previous height. How high is the ball after its 3rd bounce? It gave you a hint. Be careful what n is here. If it says you drop a tennis ball from a height, now when we're in sequences, it's a little bit goofy because that means the first term, where the ball starts at, is 15. So that's a sub 1. You haven't bounced the ball yet. You're just dropping the ball from a height of 15. So that means that we need to find our n. What is n here? Well, if a sub 1 is the starting height, that would mean that a sub 2 is the first bounce. A sub 3 is the second bounce. So a sub 4 is the 3rd bounce. So here, n is going to be 4, not 3 like you might initially think. So we're trying to find what's the 4th term because that would be the 3rd bounce. So we have a sub 1, we have n. We also need to know what 85% is. When they give you a percentage, that typically means geometric. So it means your R is going to be 0.85. That's what you multiply by every time to get the next height. This means I'm using a geometric formula. A sub 1, a sub n is the first term times r to the n minus 1. Now you have enough information that you could find the height, the fourth term, which is after the third bounce. You start at 15, you have times 0.85 to the 4 minus 1. Well, when you put that in your calculator, we should get one of the multiple choice answers here, which is 9.2, which is answer A. Alright, so that's your video on arithmetic and geometric sequences, or all geometric, arithmetic, geometric, and other sequences. Let us know if you have questions on those.